Oxford Plasmalab 80 plus reactive ion etching system. The system main power switch is right here on the front, and pump 1 is for the mechanical pump. Just turn on the pump, press the green button, and the system has an automatic pressure controller, MKS type 152. There is a turbomolecular pump on the main chamber, which is controlled by a Turbotronics NT120 controller here, and there's an RF generator. ACG-5XL ENI mark. Right now, the chamber is open after running a process. To close the chamber, rotate the switch to close position, press close button, right? And once the chamber is closed, you can start a manual process. The system can be controlled both from the front panel here or from the personal computer, which is actually an industrial PC. In order to be able to control it from here, the serial cable going to the computer should be disconnected. Once that is disconnected, this panel will be ejected. So the application software is PC Plus. On boot up, the system automatically starts the application, and there are 3 different users available: installation engineer, system engineer, or system manager. You double click on any one of them and proceed. If the main system is not powered up, the communication will fail and will indicate it. And you can run this as a manual system or an automatic system. To run an automatic program, select a recipe from the existing list, and to execute the recipe, just press the start button. You can display the status of all the parameters, process parameters, such as the vacuum level, the substrate temperature, and the mass flow controllers, and the RF power. Or we can display the vacuum chamber itself, and also in order to be able to edit a new recipe, we can select the process. To edit, you can edit the process or the materials, calibration and tolerances of each mass flow controller and pressure level controller. You can set the tolerances, the warning levels, by adjusting these values here. So in manual mode, select the status, and we can set the base vacuum level to 5 into 10 to the minus 6 torr, and the chamber pressure once the base vacuum level is reached to 50 millitorr. And we can use a couple of mass flow controllers here, and I'm just demonstrating a manual recipe here without RF power. Right now the system is being pumped down. There's the range of the CM gauge is 0 to 1 torr, and once it pumps down below 1 torr, it will start indicating the chamber vacuum level. Right now it is roughing the chamber. Once it hits around 40 millitorr, the system will start pumping into high vacuum mode. Now the penning gauge is not on yet. Now it is on, and the system is going to be pumping it down to the base vacuum level that I have set here. At any point of time, a manual process could be stopped by the stop button. When you are running a manual recipe, you can set the RF power level, but you cannot turn on the RF power from here. You have to turn it on from the generator's front panel. It's a manual process. The connections to the system rear panel. I have a mechanical pump hooked up to the main system, and I have water lines going to cool the electrode and the turbomolecular pump. The turbomolecular pump is also connected to dry nitrogen for purging, and there is an argon gas hooked up to the system for the process gases. There is an extra interlock available here to connect any external interlock such as EMO switch or a water flow switch, a compressed air switch, etc. There is an exhaust connection. While running with this process gases, the system should be connected to an exhaust line here. And there is a water dripping line here. In case of any water leakages inside, this tray will start dripping some water down there. There are a couple of extra power connections available to connect the blower packet if necessary, which could be hooked up to the pump screw switch on the front panel. This is a 9-pin serial connection to the system, which is connected to the serial port on the PC. The system requires 60 psi, 60 to 80 psi compressed air, and we can vent the chamber using a nitrogen low compressed air. It is filtered and dry. It's always good to have ground connection connected to the main system, the computer, and mechanical pump. Right now, the chamber is pumping down to the base pressure level, 5 into 10 to the minus 5 torr, or millibar. Whenever the chamber is vented, it will take longer to pump down to a very high vacuum condition, about 10 to 15 minutes. indication here, the substrate temperature is from the water line temperature. I have connected a chiller, in-house chiller to the machine to cool the turbomolecular pump and the electrodes. Here is the matching network and its controller. The matching network controller is a microprocessor control, and it controls the two capacitors, the tuning capacitors inside this box, in order to achieve maximum forward power, RF energy, and minimum reflected RF power. The matching network is not water cooled, and the maximum power it can control is 1000 watts, but the generator is 0 to 500 watts. Right now, the system crossed the base pressure level and the mass flow controllers are enabled. It's indicated by the green dot in the center. And in order to run a manual recipe, you have to set some power level here. So right now I turned on the RF manually from the generator front panel. It's a forward power of 120 watts and a reflected of less than 3 watts. I'm going to turn off the RF energy and stop this manual recipe and let us start an automatic process. There are several recipes on the system. Before executing any recipe, the parameters should be verified. I'm going to display the vacuum mode. So clicking on info will show the auto process recipe, the recipe number, and the remaining step time and logging information. And the maximum, the RF power set point here is 350 watts. And the gases I'm going to use is sulfur hexafluoride and then O2 oxygen or helium, but right now I have argon gas connected to all the mass flow controllers here. This system could be configured as a PEC video also if necessary, but the hardware needs to be changed for that. Right now this indicates the purple glow here that the plasma is on, and the RF reflected power is still tuning itself. Once it settles down, it will settle down below 5 watts. About the auto matching network, Every time the system is powered up, the reset LED will turn on. If there is a fault in the capacitors, it will be indicated by this LED. And the other two LEDs here, maximum and minimum position, when the capacitors are at their end position, these LEDs will indicate. When that condition happens, the matching network should be open, the box cover should be open, and there are fixed capacitors on the bus bar parallel to both C1 and C2. They need to be either added or removed. We'll include a couple of extra capacitors with this system. A typical capacitor is a fixed capacitor that goes into the matching network. It's attached to the bus bar using brass screws. At any point of time, in case of emergency, hit the red EMO button here, which will turn off the power to the whole system. So, it's a 4-minute recipe. The recipe just ended. And I did not include in the process steps the vent step is not included in this particular recipe. While editing the process, if you include a step to vent the chamber, then the system will finish venting So in this recipe we have included a chamber vent step. So after the process step is finished, the system will vent the chamber in order to unload the sample and load the sample. So I'll run that recipe here. Recipe which I have loaded in about 45 seconds. Now simple parameters with RF power 460 watt. And right now the chamber is pumping down to the process pressure. And the MFCs are adjusting to the well, to the values set points. And once the chamber parameter indicates that the chamber CM gauge pressure is at the process set point, the green dot indicates that it is ready to turn on the RF. The RF power is on, and the remaining step time is counting down. And at the end, the chamber will go into vent mode. So at this point, in indicating the current action is processed, and the APC, the pressure control status, it was in control mode, and now it changed to closed mode. There is no feedback from the APC status to the computer. At this point, the chamber is venting. Once it vents to the atmospheric pressure, we can open the chamber. The chamber venting process starts with the first pumping down the chamber so that all the gases are vented through the exhaust through the mechanical pump. And once the pumping down is over, then the chamber vent gases, the nitrogen gas will be entering the chamber. Right now, and there is a timer for the chamber vent duration, and after the duration we can open the chamber. So once the chamber is open, the vent gases will be disabled. Now we are ready to replace the sample. To close the chamber, select the switch to the pole position and press hoist buttons down. Chamber will close.